Hey, fifth graders. All right, so we're going to be talking about math. This is chapter 11, lesson 1, which is over polygons. So a couple of things we need to talk about before we start talking about polygons, like officially here. The first thing is a plane. So the whiteboard actually is essentially a plane, but a plane is a kind of a two-dimensional figure. It just spreads out infinitely in all directions. But it only has length and width. It does not have thickness, basically. And it is where all two-dimensional like shapes and lines and whatnot exist. Planes can go in any direction. You can have multiple planes, which is where you get three-dimensional objects, is when you have multiple planes that are coming together. However, for our purposes, just know that like anytime we're talking about line segments and anything like this, these are all just 2D figures and they're planes. So you can even draw a plane. This is not a very good drawing, but it's that. So if I ever say the word plane, I'm not referring to, I don't think I'll ever be referring to something being like ordinary, which would be P-L-A-I-N, nor am I referring to an airplane in the sky. This is plane, like a two-dimensional flat surface, basically. Okay. So a couple other things to talk about. This here is a line. Okay, a line is a two-dimensional, really it's just a one-dimensional, sorry, I shouldn't say two-dimensional, it's a one-dimensional thing that exists on a plane. It just stretches infinitely in either direction, but only in one, it's basically, it has length, it doesn't have width. It's just going it's going horizontally, it's going side to side. It's not going, it doesn't have any thickness technically, even though obviously here this has thickness. It's just impossible to draw a non-thick line, but that's what a line is. Okay, then we have a ray, which for some reason gets a capital letter. A ray, and we should actually probably refer to this first. So you can have a point. A point is just any location on a plane. Okay. Again, it really doesn't have, actually doesn't even have length or width. It's just this one infinitely small thing. However, it's basically a stopping point for lines or other things. So if we have a point here, and then from that point we have a line that stretches infinitely just in one direction, that's called a ray. So a line goes in two directions, and a line can have, an infinite number of points there. But if it just goes one way, then it's a ray, and it goes from a point. Now, if we have 2 points, that basically give us a starting and a stopping spot for our line, then this is called a line segment. Okay. And line segments, when we're talking about polygons, that's what we're really going to be dealing with, okay? So these other two, you'll use them eventually in geometry. You've maybe even already used them. Maybe you used them in 4th grade or 3rd grade or something like that, but this is the one that we actually care about today, okay? Line segment, and in particular points. So let's talk about polygons. So a polygon, and I've already drawn one, but a polygon is any two-dimensional shape, is a 2D shape. It's made of 3 or more line segments. That intersect, so they run into each other at vertices. Okay, so let's talk vertices real quick. Oh, and sorry, it's a two-dimensional closed shape. So, yeah, vertices. All right, so if I have a line segment here, and it ends right there, and then I have another line segment here. Doesn't even have to be line segments. These could just as easily be rays. This right here is the vertice. It's where the lines meet. Okay, it's the point where they both either are extending from or where they touch. Okay, now this is not to be confused with this interior part here, which is the angle. Very important that it goes LE, not EL. If it's EL, that's an angel, which is not this. So it's just terrible writing. So all shapes are going to be made of 3 or more line segments. They are all going to intersect at vertices, and the interior parts of those vertices are going to be angles. So let's talk about a couple of polygons here. Your book actually gives you a whole list of them, and they're all named based on how many sides they have. And the nice thing here is that the number of sides they have and the number of vertices that they have and the number of angles they have are all the same. If you have a piece of paper, I encourage you to try, well, I don't know if I encourage you, but I welcome you to try and draw a shape that has more line segments than it does vertices or intersections that is still a polygon, okay? So now you could do something like that, and you could say like, oh, look, see, this has got way more. It's got 1, 2, 3, 4, 5, 6, 7, 8 line segments, but there's only 1, 2, 3, 4, 5 vertices. However, this is not a polygon. Or rather, it is a polygon, but this part here doesn't matter because this is the actual polygon. And you could have argued that the triangles that were formed on the inside are also polygons, but they are not all clumped together as one polygon. They're all independent polygons. All right, so first we have the triangle. Triangle has, if you couldn't guess by the word tri, it's got 3 sides. Oops, missed a letter. It's got 3 intersecting points, and that means that it has 3 angles. Okay, so obviously you guys all know what a triangle looks like, right? And you can draw triangles any way you want. Okay, no matter what, 1, 2, 3 sides, 1, 2, 3 points where they intersect, 1, 2, 3 angles. And you'll have a later chapter that deals all with triangles. Okay. Then we have quadrilaterals. Which might have misspelled, whatever. Okay, quadrilaterals have 4 sides, 4 vertices, 4 angles. Cool? So far, makes sense? All right, then we have pentagons. And triangles and quadrilaterals are the ones that kind of have the weird names. Not so much because of, well, after this, it just gets a lot more regular. You have a gon at the end, all right? So we have pentagons, which are 5, 5, and 5. We have, let me make sure yeah, okay, good. All right, so then we have hexagons. Which are 6, 6, and 6. You kind of get the idea here, right? So it's going to go from this just through all the rest of them. So we go pentagon, hexagon, heptagon is 7, which is kind of a weird one that you won't run into a whole lot. Octagon, you guys have probably heard, either gentlemen or ladies who like UFC, the octagon, or maybe you've just heard of it somewhere else. But an octagon is an 8-sided figure. A nonagon is 9, which is maybe one that you've definitely not heard of. And then we have a decagon, which is 10. Deca being 10. Decade, decameter, 10. Okay? All right. So all of them are going to be 10, 10, 10, 10, 10. Cool. So the other 2 vocabulary words that you need to be aware of for this lesson are actually very, very closely related. So we have congruent, and then we have regular. All right, now, we have talked about congruent before. You guys have seen that before, particularly when we were talking about fractions. For instance, 1/4 is equal to eighths, which is equal to 3/12, right? All of these are congruent fractions. Okay, they're equal to each other. They're the same, really. It's just they're in different forms. Okay, so congruent when we're talking geometry means the same. Okay, so if I have this right here means 90 degrees if you have a two line segments here that intersect and it forms a 90-degree angle. You put a little box in there and that just symbolizes that that's 90 degrees because obviously if we were to measure this out, we would find that it is not 90 degrees because as a human, I can't draw a perfect 90-degree on the dot angle. However, you know, I put that little box there or the little square there and then everybody knows like, oh, okay, that's supposed to be 90 degrees. Okay, so if I have one there and then I have one over here, right? These are both 90 degrees, so these are congruent angles, okay? All right, they're both 90 degrees. They're equal to each other, so that makes them congruent, right? If you have side lengths, so if I say that this length here is, I don't know, we'll say 5 inches. And then I have another line over here that is 5 inches. Those are congruent, right? They're the same length, okay? And when it comes to line segments, what we do is we actually put just like a little dash through them, and that tells us that they're the same. So if I just had it like this, so I said this is 5 inches, and it's got this little dash through it, and this little dash through it, and maybe we'll say that this is part of a polygon. So we'll make it, there, it's a quadrilateral now. Okay, 1, 2, 3, 4 sides. Okay, and I say there's a line there and a line there. That means that these are both 5 inches long. Okay, we don't know what the lengths are for the other ones, but because we see that little line, that means that they are both the same, that they're considered to be the same. All right, so that's congruent. Now, regular is a polygon with basically like all congruent. Ugh, spelling is hard. All right, so if it is a regular polygon, that means that all of the sides are the same length and all of the angles are the same length. So let's take a look at what this looks like. All right, so you guys have probably all seen this shape before. I'll try to draw it roughly pretty close, but put that there, and that there, and that there, and that there. Okay, so here we have a shape. It's got 4 sides. Every single side is 90 degrees, and every single angle is 90 degrees, and every single side is congruent. They're all the same length. Okay, what shape would that be? That'd be a square, right? So this one is actually a regular quadrilateral, okay? But we give it the special name of square. Not all of them have special names, but some of them do. Let's say that we had I think this is one that comes up as an example for you. And this is in no way, by the way, drawn correctly, but we're going to use our imaginations and assume. When I was younger in high school, we would sometimes put little lines through the angle, whatever it's called, semicircle, just to symbolize that those are also, equal to other ones that have a line through them, and some of them would have 2 lines through them. Doesn't really matter. I think your book just uses other things. Will do like, okay, so you can have this, right? and then it would have another one that would be, sometimes you do that where you have two lines, or sometimes you just put a dash through one and two dashes through another one. All means the same thing. Doesn't really matter. It's pretty easy to see what it is that whoever's drawing it is doing. But just know that there's a couple different ways to do it. I'm not sure what the official one is. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8. So it's an octagon. Okay, it's an octagon, and all the sides are the same length, and all the angles are supposed to be the same. They're not, but they're supposed to be the same. So we would call this a regular octagon, right? Pretty simple. Okay, so I believe on your book, they just want you to, okay. Yeah, so really what they want you to do is, for most of this, is you're going to identify the shape, and then you're going to tell if it's going to be regular or not regular. The book writes it out as not a regular polygon. You can just write irregular. So if I have, let's do it this way. Let's make a new one. So let's say I have this shape here. Okay, and we're going to pretend like those are all the same. Okay, so this would be a regular triangle. It's also called an equilateral triangle, but we'll talk about that here in a later chapter. All right, then I have this shape here. All right, so those angles are the same, but this one is different. This is an irregular triangle. Anyway, I hope that helps. Good luck. Have fun. Talk to you later.